This video is just a quick example on Newton's law of cooling. So Newton's law of cooling looks like this. It's U of T is equal to capital T plus capital N naught minus capital T times e to the kt. Now in these cases here, for these letters are U is the temperature of the heated object at whatever time in the future or currently. And T is, well, that's time, either in seconds or minutes, depending. Capital T is the constant temperature of the surrounding medium. So let's say your object is in a room that's 72 degrees. Then capital T would be 72. Or if your object is in a refrigerator, then capital T would be the temperature of the refrigerator. U naught, or rather N naught, is the initial temperature of the object. So we're heating it to some temperature U, and it started at a temperature N. Heating or cooling to some temperature U. And then K is a constant again. So our example says, an object is heated to 100 degrees Celsius. It is left to cool in a room that has a temperature of 30 degrees Celsius, cold room. After 5 minutes, the temperature of the object is now 80 degrees, which makes sense. If the room's that chilly, then your object is going to cool. Use Newton's law of cooling to find a model for the temperature of the object after T minutes. So using our formula, we'll plug in. So the object is heated to 100 degrees. So N naught, the temperature that it starts at, is 100. It's cooling in a room that has a temperature of 30 degrees. So T is 30. We're looking for K, and it's heated to, or it's cooled to 80 degrees Celsius in 5 minutes. So using this information, the only thing we don't know now is K, and so we can find it. 100 minus 30 is 70. And we cannot add the 30 and the 70 because the 70 is being multiplied by the e to the 5k, and multiplication comes first. So we can't do that, but we can subtract 30 from both sides. And now we can divide by 70. So we would end up with 5/7 equals e to the 5k. We're going to take the natural log of both sides. And so 5k is equal to the natural log of 5/7. So K would be the natural log of 5/7 divided by 5, which is approximately negative 0.0673. So our model would be U of T equals our starting temperature, 30, plus 100 minus 30, which was our 70, times e to the k, which is negative 0.0673 times t, where t can be any time in minutes. So it asks us what's the temperature of an object after 20 minutes. So all we need to do is plug in 20 for t. And you can just put that in your calculator and get about 48 degrees Celsius. And then lastly, it asks us, when will the temperature of the object be 35 degrees Celsius? So we want the temperature to end up 35 degrees. And we need to find T. So subtract 30 from both sides. Divide by 70. Take the natural log of both sides. So negative 0.0673 t is equal to the natural log of 5 over 70, or t is the natural log of 5 over 70 divided by negative 0.0673. It's approximately 39 minutes. And so there's your example on Newton's law of cooling.